know you've been looking forward to that all day. So let's do some more properties. You ready? Quotient. What's quotient? Yeah, it's a division. So quotient of powers. Here we go. To divide powers having the same base, you keep the base and subtract the exponents. Now, yesterday, when you were multiplying powers with the same base, what did you do to the exponents? You added them, right? This says subtract here. When you're dividing, you subtract. So, there's a lot of talking going on. So here, using the quotient of powers property, we are dividing powers with the same base number, so all you would do to get your answer is do 9 to the 12 minus 5, which is 9 to the 7. And I'm going to show you a simple problem as to why this is true. Let's say we have this, 3 to the 4th divided by 3 squared. This means this, right? 3 times 3 times 3 times 3. And this means this, right? Okay, if you cancel two of these, what are you left with? 3 squared, which is the same as 3 to the 4 minus 2, which is 3 squared. That's why it works, okay? So here, this is saying you had 12 nines on top, 5 nines on bottom. You cancel out 5, you're left with how many? 7. See what I mean? Yeah. Okay, same base, division, all we do is subtract the exponents. So how many negative 2's do we have here?
1.
Negative 2 to the first power, or you could just write it like this. Either way, it doesn't matter. Okay, now we're going to start combining some things, what we learned yesterday and with what we're going to do today. So when you have something like this, what do you think you should do first?
Add the top.
Let's add the top. We have 7 sixes on the top, don't we? 3 plus 4. And on the bottom, it's still 6 squared.
5.
So yeah, there's 7 sixes divided by 2 sixes. That leaves me with 5 sixes. Yes?
On the test, would you like us to do the 6 to the 7th power divided by 6 to the...
I'd like you to write this, maybe, yeah, and then do that. Okay? All right, now let's talk about this one. Hey. Brian's ahead of me. Can you put anything over 1? Any number, right?
Yeah.
Anything. So I'm going to rewrite this as 1 over r to the 5th times r to the 8th over 1.
Oh, you know. What if the second die multiply, bro?
No, we're not dividing. That's only when you divide.
Do you cross multiply?
No, you don't cross multiply. When you multiply fractions, you just go straight across. You just go straight across. That's not a negative, no. See where that came from? If you don't want to write all that out, just know that that goes on top. Right? That multiplies by whatever's on top. Now we're not done, are we? No. We subtract the exponents. 8 minus 5, and it equals r cubed. Okay. Quotient of powers was up here. Excuse me, you guys, stay with me. Hey. Here is power of a quotient. This is a little different. To find the power of a quotient, find the power of the numerator and the power of the denominator. You actually kind of did it already yesterday. You have a fraction. Distribute the exponent. Once you did this already yesterday, but that's okay. We'll write it out. To both the numerator and the denominator. Let me remind you, your notes count for points in your portfolio as well, correct? So be thorough, just like whatever I have up here. Okay, so you did this yesterday. So we just put the 6 on the numerator and the 6 on the denominator, and it looks like this. And that's all you can do. Can you cancel? Can you subtract anything here?
No.
Why not?
Be 0.
They're not the same base, so you have to leave it like this. This is all you can do with this. Note to yourself.
I would have done it.
Base not the same. Can't subtract exponents. Can't subtract exponents. Okay? Let's distribute that 4, so it's going to look like this. Negative 2 to the 4th over y to the 4th. We could do that numerator. That's a kind of an easy one. What's negative 2 to the 4th? Is it going to be a positive number or a negative number? Positive, because it's an even exponent. 2 times 2 times 2 times 16, right? It's like 2 times 2 times 2 times 2. I don't want to say it too many times. So equals 16 over y to the 4th. Okay? All right, turn it over. So now we start putting a bunch of stuff together. Yesterday's stuff, today's stuff, we'll put it all together. Okay, use the properties of exponents. We're combining 8-1 and 8-2, and there's more than one property in these problems. Shall I wait? We got 4 problems to do. You ready? I'll wait. Let's look at this. We got all this stuff raised to the 3rd power, right? We got to put that 3 on everything that's in that fraction. All 4 things you put that 3 on. So it looks like this. You ready? 3 to the 3rd.
Oh, hold on, dude.
We're putting that 3 on everything. And then I'm going to do a to the 4th to the 3rd, which would be a to the... We're multiplying. Power to a power is 12. A to the 12. Over 5 to the 3rd. And then b to the 3rd. Now, do we have the same base anywhere in this fraction? No. So really the only thing we could do is 3 to the 3rd. That's kind of a small number. What's 3 to the 3rd? 27. We could do that, or we don't have to. We could just leave our answer like this. There's nothing else we can do with that.
What about 5?
That's 125. You could if you want to. Yeah. Okay. All right, that one was easy. Let's do another one. You ready?
Yeah.
Okay, we got a 7. We're going to put it on both of these things here. I want you to make a note to yourself. Why do I not put the 8 on the 3 here?
Because it's not being added.
There's no parentheses around it. Okay? So make a note to yourself. No parentheses. So you don't put the 8. Put the 8 on the 3. So let's rewrite what we have now. I'm going to go down here. X to the 3rd to the 7th is actually x to the what? 21. You multiply those two together. And then y to the 7th. And I'm going to multiply it by this fraction. When you multiply fractions, you go straight across. So 1 times that stuff is just that stuff. So that's my numerator. Do I have a like base here, or are they different bases? So you don't add them. You don't add the exponents. You just put them together. You always put the 3 first, and then y to the 7th, x to the 8th. That's actually, oh, we're not done yet. Why are we not done yet? Look at this. We have an x on top and an x on bottom.
And.
So I have, just hold on, I have 21 x's on top and 8 x's on bottom. If I subtract them, I'm going to have leftover where?
13.
On top, right? 13 still on top. Does that make sense?
Yes.
So I would say it doesn't, no, it's okay. It's just multiplies, so it doesn't matter. X to the 13 over 3y to the 7. And I can't do anything else with that. Do you all see where that 13 came from?
Yeah.
21 minus 8.
Yeah.
And there's more on top, so that's where they go. Okay? Wasn't that fun?
No.
Yes.
Let's do another one. Two more together. Okay. I can't do anything with this fraction. I'm going to leave that, just leave that for now. There's no distributing to happen. There's nothing on that fraction. However, on this one, I've got to distribute that 3. So in my numerator, I'm going to have m to the 4th to the 3rd, which means m to the 12th. And then n to the what? 6. 2 times 3. Okay, when I multiply fractions, I go straight across, so I'm just basically going to combine them. 3m to the 12th over 8m to the 5th, n to the 6th. I think they used to be these didn't bleed through. It drives me nuts. I think they changed the paper. I think it's thinner. They have different paper. Okay, now watch this. Hey, cover this up. See the 3 8s there? Can you reduce that fraction, or is it as reduced as it can be? It is. But if you could reduce it, you need to. But we can't. So that's going to stay the same. That's going to be part of my answer. So I'm going to write that.
It's unnecessary.
Yeah, that's rude. Don't do it when I'm talking. Not right now. Okay, now let's look at the m's. We did that part. Look at the m's. Same base. There's 12 on top, 5 on bottom. So when I cancel, I'm going to have leftover on top. How many? 7. And then n to the 6th, I can't do anything with, so that stays on the bottom. That's it. Yeah? Do you want to try this last one on your own?
Yeah, I want to try it.
Try it. Get it started, and then I'll do it with you. You good?
I got that right.
Now, let's just put them all together. Watch this next step. I should close that door.
Joe, stop.
You stop.
Doing what?
Everything.
Okay. Now, let's put them all together in the one numerator and one denominator. So I'm going to draw one big line. What's 2 squared? 4. That's easy. Let's make that a 4. I did that one. Cross it off. Okay? Look at this numerator. I have m to the 10 in the numerator and m squared in the numerator. So how many m's do I have in the numerator? 12. I have 12 m's in the numerator, don't I? So I'm going to write m to the 12th. I took care of those two. And then I have n squared and n to the 8th. So how many n's do I have in the numerator? 10. That's my numerator. Let's do the denominator now. 4 squared is what?
16.
16. And I also have 5 squared here. So I'm going to do times 25. See that? I had 4 squared and 5 squared. So I wrote them both down here. And then I have n to the 4th and n squared. I can't combine them, so I'm just going to write them both down in the bottom here. Okay, we're close, Wait a minute, Oh, look at that. I can reduce that fraction. What's that reduced?
64.
So I'm going to write another big one. 1/4. So I took care of that. 1/4. I still have the 25, so I'm going to write that. I still have the 25. Okay, let's look at the M's now. See how I'm covering up? Okay, I'm going to work with the M's. I have 12 on top, 4 on bottom. If I cancel, how many do I have left where?
On the top.
I have 8 left over on the top. Look at it as 12 M's divided by 4 M's. You cancel out the 4, you still have 8 on top, right? Okay, I did that. Okay, now do the N's. 10 N's, 2 N's. I have 8 left on top, don't I, when I cancel? Okay, there's just one last thing we could do to make it pretty. Yeah, multiply the 4 and the 25. So this equals, I'm not going to write the 1. I don't need the 1 in the numerator. Over 100.
Keep it 100.
Look at that. That came from that. That's pretty cool, isn't it?
It's sun right now.